In 1970, Allis Chalmers attempted something no manufacturer had ever dared: build a production bulldozer more powerful than Caterpillar's flagship. If they failed, they would cripple their construction division. If they succeeded, they would force every competitor on Earth to redesign from the ground up. The machine weighed 70 tons. It produced 524 horsepower. And for a brief moment, it was the most powerful crawler tractor ever put to work. The HD-41 didn't just challenge Caterpillar, it humiliated them. For 3 years, it was the undisputed heavyweight champion of construction equipment. Then the final drive started failing, and Caterpillar showed up with a machine that would end the war. The giant killer heritage. Allis Chalmers had been building the impossible since before most equipment manufacturers existed. In 1945, they put the first torque converter on a crawler tractor, a technology Caterpillar wouldn't adopt for years. They pioneered lifetime sealed track rollers and idlers when competitors were still demanding operators grease their machines daily. While other companies made incremental improvements, Allis Chalmers made leaps, and they had a particular talent for humiliating Caterpillar on size. In 1940, the HD-14 became the most powerful crawler tractor on the market at 132 drawbar horsepower. Caterpillar had nothing close. In 1947, Allis Chalmers claimed the world record again with the HD-19, 163 horsepower, 25 tons with a dozer blade. It stayed the heavyweight champion for years. This wasn't accident, this was philosophy. Allis Chalmers believed that innovation beat incremental improvement, that taking risks beat playing it safe, that being first mattered more than being careful. By the early 1960s, the construction equipment arms race had intensified. Caterpillar's D9 dominated job sites worldwide. International Harvester was pushing harder. The market was consolidating around a few major players, and if you weren't growing, you were dying. Allis Chalmers engineers started asking a dangerous question. What if we went bigger than anyone thought possible? Not 10% bigger, not 20% bigger. What if we built something that made the D9 look inadequate? The super dozer concept was born. 7 years in hell. In 1963, Allis Chalmers rolled a prototype onto the floor of the Chicago Road Show. 70 tons, over 500 horsepower. A blade that could swallow 2 cars. Contractors crowded around it like pilgrims at a shrine. Caterpillar engineers stood in the back and did math in their heads. The competitive advantage calculations were brutal. If Allis Chalmers could actually build this thing at scale, every major earth-moving contractor would want one. Strip mines, dam projects, highway construction, anywhere you needed to move massive amounts of material fast. The applause was deafening. Then Allis Chalmers told everyone the bad news. It wasn't for sale yet. The prototype was proof of concept, a statement of intent. But building a handful of experimental machines was one thing. Producing hundreds of them reliably was another problem entirely. The first issue was power. Diesel engines capable of reliably producing over 500 horsepower didn't exist in a package that could fit in a crawler tractor. Allis Chalmers needed Cummins to develop something that had never been built before, a turbocharged V12 that could run day after day in conditions that would kill a truck engine in weeks. Cummins went to work on the VT-1710C, a 1,710 cubic inch monster with twin turbochargers. The engineering challenges were immense: cooling systems, vibration, reliability under sustained load. Then there was the metallurgy problem. When you're generating that much power and torque, every component in the drivetrain becomes a potential failure point. Final drives, steering clutches, track frames. Allis Chalmers was pushing into territory where the steel itself had to be better than anything they'd used before. They built prototypes, sent them to mine sites, quarries, massive earth-moving projects. Watched what broke, redesigned, built more prototypes, watched what broke again. 7 years. From 1963 to 1970, Allis Chalmers iterated, tested, and refined. Customers kept asking when they could buy one. Salesmen kept saying, soon. Engineers kept finding new things that needed fixing. Meanwhile, Caterpillar was watching. The beast. When the HD-41 finally entered production in 1970, it was everything Allis Chalmers promised and more. The Cummins VVT 1710 CV12 delivered 524 flywheel horsepower. To understand what that meant, Caterpillar's D9H, the industry standard for heavy work, produced 410 horsepower. The HD-41 had 114 more horses. That's not a marginal advantage. That's a different weight class. The machine measured over 20 feet long, 11 feet wide, and 13 feet tall. The tracks alone came up to a 5-foot 9-inch operator's shoulders. With a semi-U blade and ripper attached, it weighed 70 tons, 140,000 pounds of diesel-powered earth-moving fury. The blade options ranged up to 20 feet wide, 20 feet. You could park 3 pickup trucks side by side in that blade. But the specs only tell part of the story. What mattered was what it could do. The HD-41 could rip bedrock while traveling uphill. Let that sink in. Most dozers had to stop, drop the ripper, and pull forward slowly to tear through hard material. The HD-41 could rip on the move, even climbing grades. Operators reported working in conditions that would bog down a D9 completely. Loading times for scrapers dropped dramatically. One HD-41 with a push blade could do the work of multiple smaller machines. In strip mining, where speed equals money, that productivity gap was game-changing. Allis Chalmers made some clever engineering choices too. They knew an engine that powerful would generate enormous heat. Instead of jamming everything into the engine compartment like competitors did, they moved the hydraulic and transmission oil coolers behind the operator's cab. Hydraulically driven fans pulled cool air through the cores and exhausted it away from the machine. This kept the engine bay cooler, extended component life, and made the operator's station more tolerable. The controls were surprisingly simple. Everything hydraulic, steering levers, throttle, and transmission controls grouped on the left, blade and ripper controls on the right. For a machine this massive, operators found it intuitive to run. Sales took off immediately. In the first 4 years, Allis Chalmers built approximately 1,900 HD-41 units. On job sites from Wyoming coal mines to Australian quarries, the orange giants became the machines everyone wanted. Contractors who'd been loyal Caterpillar customers for decades started calling Allis Chalmers dealers. The conversation usually went the same way. "I need something bigger than a D9. What have you got?" The answer was always the same. "We've got the biggest thing on Earth." For 3 years, that was absolutely true. The fatal flaw. The operators noticed it first. Final drives were failing, not occasionally, regularly. In heavy ripping, hard rock, sustained loads, the kind of work the HD-41 was specifically designed for, the final drives would tear themselves apart. Some machines went through 8 final drives in work that should have been routine. The problem was fundamental. Allis Chalmers had built a drivetrain capable of handling 400 horsepower, and then asked it to handle 524. The math worked on paper. In the field, under sustained punishment, the steel couldn't take it. Contractors in Australia started detuning their HD-41s by 80 to 100 horsepower just to keep them running. Think about that. You buy the most powerful dozer on Earth, and within months you're deliberately reducing its power because otherwise it destroys itself. The phrase operators used was brutal. They could outwork anything on Earth when they were working. Allis Chalmers engineers scrambled to fix it. Upgraded materials, design modifications, field retrofits. But the core problem remained. They'd pushed the envelope too far, too fast. The ambition that made the HD-41 possible was the same ambition that made it unreliable. And while Allis Chalmers was fighting fires, Caterpillar was designing the future. In 1973, just 3 years after the HD-41 entered production, Caterpillar showed the first D10 prototype at an internal corporate meeting. The message was clear. If Allis Chalmers wants a war, we'll end it. The D10 wouldn't arrive until 1977, but when it did, it made the HD-41 look like a warm-up act. 700 horsepower, 180,000 pounds, a 1,786 cubic inch V, 12 with twin turbochargers, and Critically, a drivetrain engineered from the ground up to handle that power reliably. Caterpillar had learned from Allis Chalmers' mistakes. They'd watched the HD-41 fail in the field and engineered solutions before their machine ever shipped. The elevated drive sprocket design, unique to Caterpillar, improved durability and reduced maintenance. Then Komatsu entered the fight. In 1976, the Japanese manufacturer unveiled the D455A, 620 horsepower, 167,000 pounds. Suddenly, the HD-41 wasn't just outgunned by Caterpillar, it was outgunned by everyone. The super dozer race Allis Chalmers had started was leaving them behind. Fiat and the end. In 1974, Fiat SPA of Italy purchased a controlling share of Allis Chalmers. The Fiat-Allis joint venture was formed, and the construction equipment division got new ownership, new management, and new pressure to turn the HD-41 into a profitable line. The upgraded 41B model appeared that same year. Fiat-Allis dropped the HD prefix. It was now just the 41B. They incorporated lessons learned from 4 years of field failures. Better final drives, improved components, more robust engineering throughout. It was better. Operators confirmed it. The 41B was more reliable than the original HD-41, more capable and sustained heavy work. The catastrophic final drive failures became less common, but it wasn't better enough. By the time the 41B improvements reached the market, Caterpillar had already been selling the D10 for years. The D10 worked. It was reliable. It was backed by Caterpillar's legendary dealer network and parts availability. Contractors who'd gambled on the HD-41 and lost money on downtime weren't interested in giving Fiat-Allis a second chance. The market had moved on. Production continued through the late 1970s, but the numbers told the story. Approximately 764 units of the 41B were built between 1974 and 1982. Total production across all HD-41 variants was around 2,700 to 3,000 machines. Compare that to Caterpillar's D10, nearly 1,000 units built between 1978 and 1986, and that was just the first generation. The D10 outsold the HD-41 and Komatsu's competing models combined. In 1982, Fiat-Allis built the last 41B. Unit number 764 rolled off the line in Springfield, Illinois, and the era ended. Fiat-Allis tried to continue the superdozer lineage with the FD40 and FD50 models, but they were short-lived. Market conditions softened in the 1980s. By 1989, Fiat-Allis had transferred all earth-moving equipment manufacturing to Italy and eventually wound down operations entirely. The irony is almost poetic. Allis Chalmers, the company that started the giant tractor race in 1940, the company that forced everyone to build bigger and more powerful machines, was the first to quit. They'd fired the opening shot in a war they couldn't win. Legacy. Today, HD-41. SS are rare. With only 2,700 to 3,000 ever built across all variants, and most of them work to death in mines and quarries, survivors are collector's items. Some still work. There's a famous story of a 1972 HD-41 that sat rusting beside railroad tracks in rural South Carolina for years. A collector named Roy Ashley paid $10,000, its scrap value, and hauled it to Georgia, restored it, ran it at tractor shows. The machine still exists, still runs, still terrifies people who stand next to it. At tractor pulls, HD-41s are legend. One operator had to be flagged to stop because the dozer was about to pull the drag sled apart and leave the fairgrounds. It showed no signs of slowing down. But the real legacy isn't in the survivors. It's in everything that came after. The HD-41 proved that super dozers were possible, not just theoretically, but practically. You could build a machine with over 500 horsepower, put it to work in the hardest conditions on Earth, and, if you engineered it right, it would revolutionize productivity. Caterpillar's D10 succeeded where the HD-41 failed because Caterpillar learned from Allis Chalmers' mistakes. The D11 followed, then larger machines still. The entire modern lineage of ultra-heavy crawler tractors exists because in 1963, a company in Milwaukee decided to build something impossible. The HD-41 also taught the industry a harder lesson. Ambition without execution is just expensive failure. You can have the vision, you can have the courage, you can build the prototype and wow the crowds and dominate the headlines. But if the final drives can't handle the power, if the engineering can't support the ambition, if you can't deliver reliability at scale, someone else will learn from your mistakes and beat you with your own idea. That's what Caterpillar did. They watched the HD-41 succeed and fail, took notes, and built something better. Modern equipment engineers still study the HD-41, not as a triumph, but as a cautionary tale. It's a reminder that being first doesn't guarantee being best. That innovation without durability is just a prototype. That the market doesn't reward vision, it rewards results. The machine that changed everything. In 1963, a crowd gathered around a prototype bulldozer in Chicago and witnessed something that shouldn't have been possible. 70 tons, 524 horsepower, a blade that could move mountains. It took 7 years to bring it to production, 3 years to dominate the market, and less than a decade for competitors to surpass it. The Allis Chalmers HD-41 was flawed, fragile, and ultimately a commercial failure. But it changed the industry forever. Every superdozer that came after, the D10, D11, Komatsu's D475, the modern behemoths that reshaped continents, exists because Allis Chalmers proved it could be done. They started a war they couldn't win, but they forced everyone else to fight it. And in the end, maybe that's legacy enough. If you operated, maintained, or worked alongside an HD-41, I want to hear your story. Drop a comment below. What did you think of the machine? What broke? What impressed you? Let's keep this history alive.